Good morning. Today we are starting a new chapter in class 9th, chapter number 3, coordinate geometry. And this will be according to new syllabus. Let's start. First of all, a little introduction. We have already studied how to locate a point on a number line in the previous chapter. And there are many other situations in which we have to find a point. We are required to describe its position with reference to more than one line. For example, consider this situation. So we can see here this is a west direction and this is east direction. So this is west direction and this is east direction. So uh, consider this as a road. This is a main highway road, and these are the streets connecting to the main highway. This is street number 1, this is street number 2, this is street number 3, 4, 5, 6, 7 and 8. And these are the houses on the street. House number 1, house number 2 on street 1, house number 3, house number 4, house number 5 on street 1. Similarly, there are other houses in different streets, 1 2 3 4 5, 1 2 3 4 5. Okay, now what we have to do here is we have to locate this house. If someone tells us to locate a house on street number 7, on street number 7 and house is 4, so this is very easy for us, that we have to go to street number 7 first, and then on street number 7 we have to find house number 4. But what if we get only one information? That is, if someone tell us to locate house number 4, house number 4. So if you can see, there are house number 4 in all the streets, so it will not be possible for us to locate houses on by only one information, that is house number 4. We cannot locate it because all the streets have similar number of houses, similar name house. Okay, what if someone tell us that locate a house in street 2? So if you can see here, we can reach to street 2, and there are many houses in street 2, 1 2 3 4 5. Then it will also be very difficult for us to locate a house if we have one information. So if we want to locate a particular position in a street, we need to have 2 point information. We need to have 2 point information, 2 pieces of information. That is, we need to have the street number, that is 7, and then house number, that is 2 or 4, anything. So we can locate it easily. So like here we have located on street number 7 house number 4. Okay, similarly we need to find house number 5 on street number 2. So what we will do, we'll move from west to street number 2, which is on the right hand side, and then on street number 2 we'll move from 1 2 3 4 5, and we can locate easily house number 5. So this is an example that we need to have 2 pieces of information to locate any point on on a on a street, or to locate any point on a plane. Okay, take one more example. Here what we have a sheet of paper. This is our sheet of paper, and there is a point here, and we need to give the position of this point on the paper. What information do we have? We have the length and breadth. We have this information. We have the length of this paper and we have the breadth of this paper. With this information we have, and we want to locate a point. Suppose we have one information, that is that the point is above 6 centimeter from bottom. So What we know now here is that the point is 6 centimeter above the bottom line. Okay, so now we can assume that this point is somewhere above 6 centimeter from the bottom line of the plane of the paper. So this point can be anywhere here. Okay, this point can be anywhere here. Now again, if we want to locate the exact location, we need to have one more thing, that this point is on the right of the left border of the paper 5 centimeter. What do we have, that this point is 5 centimeter from the left border of the paper. So this is 5 centimeter and this is 6 centimeter. So this point is 5 centimeter from the left border of the paper. So now we know that this point is 5 centimeter from the left border of the paper. So this is the point. We can see here is there is only one place where this point locates, which crosses both the information, that is this point. So this is left 5 centimeter from the left border and 6 centimeter from the bottom border. So we can locate this point. So we need to have two pieces of information for locating any point on a piece of paper, and both this information are two independent information. Take one more example. Here this is a classroom. In this classroom we have seating plan in rows and columns. This is our teacher's desk, and these are the desk for each student by one block. Okay, so we have 7 rows and 10 columns, 7 rows and 10 columns. Okay, now if you want to show this student named Sonia desk on a location, we want to show Sonia's desk location. What we'll do is, first we will find out that on this on this seating plan, where does Sonia sits. So she sits on the 4th column. If you see here, she sits on the 4th column, which is 4th column. Okay, this is 1, this is 2, this is 3, this is 4. This she sits on the 4th column. But on the 4th column we can see there are 7 seating arrangements. This is 1 2 3 4 5 6 7 7 seating arrangement. So we have to find the row also. So she sits on the first row. So these two pieces of information, we can find the place of Sonia where she sits on the classroom. So if we write here is, when we write column comma row, we can write here is 4 comma 1. So this is the location where she sits. So from the above examples we can clearly see that uh, that the position of any object lying on a plane can be represented with the help of two perpendicular lines. In case of dot, we require distance of the dot from the bottom line as well as from the left edge of the paper. In case of seating plan, we require the number of column and that of the row. This simple idea has far-reaching consequences and has given rise to the very important branch of mathematics known as coordinate geometry. In this chapter, we'll aim to introduce some basic concepts of coordinate geometry. This study was initially developed by French philosopher and mathematician René Descartes. So exercise number 3.1, page number 45. Question number 1. Question number 1 asks, how will you describe the position of a table lamp on your study table to another person? So what we have here is a table, and we want to describe the position of this lamp here sitting on the table. How will you describe? So there is only one way we can describe this position on the table, is that if we have two pieces of information. First, that is the location of the lamp from the left border of this table, and the position of lamp from the bottom border of this table. Or one more thing we can do, if we have the location of the table lamp from the right border of the table or from the top border of the table, so at least we need to have two pieces of information which are independent of each other. Okay, so one thing, either we have location of lamp from right border or left border, that is one. And second, either from location of the lamp from top or bottom border. So we need to have these two information, from the left or right border or from the top and bottom border. When we have from left border, so we can locate it here, and when we have from bottom border, we can locate it here. If we have the location from left and from top, we can locate it here. If we have from right and bottom, we can locate it here. If we have from right and top, we can locate it here. So any two pieces of information is necessary to locate table lamp on a table. Question number 2. Question number 2 says, there is a street plan. A city has two main roads which crosses each other at the center of the city. So this is, let us consider this is the center of the city, and there are two roads. One crosses here, one crosses here. Let us assume this is the center of the city. These are the two roads. One is from north to south, and one is from east to west. Okay. Now, all the other streets of the city run parallel to these roads and are 200 meters apart. That means all the other streets are parallel to these roads. That means this is one road, this is two road, this is three road. All these are parallel and are 200 meters apart. Okay, and there are 5 streets in each direction. So 1, 2, 3, 4 and 5. Similarly from here, 1, 2, 3, 4 and 5. These are parallel. Pardon my drawing, which is slightly slanted, but assume this is parallel. So we have got our roads. Each road is 200 meters from the main road. Okay, now there are many cross streets in your model. What these are the cross streets? All these are cross streets. Okay, a particular cross street is made by two streets, one running in north south direction, and another in east west direction. Each cross street is referred to in the following manner: if the second street running in the north south direction and fifth street in the east west direction, second in the north south and fifth in the east west, that means this one, direction meet at some crossing, then we will call this is cross street as 2 comma 5. Okay, using this convention, find question number 1: how many cross streets can be referred to as 4 comma 3? 4 comma 3. So by using the given convention, this will be our north south and this will be our east west, right? So north south 4th street, north south 4th street will be this one, north south 4th street will be this one, and east west third street will be this one. So the cross street will be this one, this will be our 4 comma 3. Okay, second, how many cross streets can be referred to as 3 comma 4? 3 comma 4. So for the one, how many cross street, there can be only one cross street, unique cross street which can cross 4 comma 3, and now we have to find 3 comma 4. So this will be north south and this will be east west. So north south, how many cross street? North south 3, this one, whole this lines, this will be the north south street, and fourth east west, fourth east west means this one, this one. So 3 comma 4 will be this one, so 3 comma 4. So again we will get unique cross street named 3 comma 4, that is 1. So here we have exercise number 1 completed. Now we will start Cartesian system. We have studied number line in the number system. On the number line, distances from the fixed point are marked as equal unit positively in one direction or negatively in another. But the point from where the negative and positive starts is called its origin, or 0. So this is called the origin or 0. Here we can move right hand side, that is positive, and left hand side, that is negative, and all these are 1 unit apart on the positive direction and 1 unit apart in the negative direction, and all fixed 1 unit. Each number is fixed 1 unit apart. Okay, so when we write these units in a single line, these are, will be, center will be origin and positive side will be fixed units which is 1 unit apart, and this 1 unit can be any number, 2 centimeter, 3 centimeter, but it will be fixed for all the points like this, -1, -2, -3. These all will be equal and fixed 1 unit. Okay, now if we take one horizontal line similar and we take one vertical line, which is 90-degree horizontal and vertical line. So we can locate a point in this plane. So this point will be somewhere uh, somewhere on the horizontal line. We can locate it here, and somewhere on the vertical line we can locate it here. So it will be very easy for us. So what we will do here is we can take all these planes like this, in any direction, but usually we will take perpendicular to each other vertically and horizontally. Okay, we will take two lines, one horizontal, we'll name it as x and x bar, and one vertical, y and y bar, and all these line will be having one origin 0 and positive side by equal fixed unit 1 2 3, and negative side equal fixed units. Similarly, on the vertical side we'll have similar. On the top above we'll have positive 1 2 3, and on the bottom or from the origin we'll have negative. And when we combine these two, what we get here is this. When we combine both horizontal and vertical line, we'll get 0, and we'll get a positive x-axis 1 2 3 4 5 6, and negative x-axis -1 -2 -3 -4, like this. And on the vertical side, on the top we'll get positive y-axis, and on the bottom we'll get negative y-axis, and center will be the origin. Now what we have here is a plane which is divided into 4 parts. Okay, 1 2 3 4 parts. Okay, on this plane we can locate any point. If given like this, we can locate any point, and we can exactly find the exact location of that point. Okay, since we have a plane which is divided into 4 parts, we name it as quadrant. So this will be our first quadrant, this will be our second quadrant, this will be our third quadrant, and this will be our fourth quadrant. We'll move anti-clockwise from first to fourth, and this is called Cartesian plane or coordinate plane, because we find the coordinates of a point on this plane. Therefore it is called coordinate plane or the Cartesian plane or the xy plane, because what we have denoted here is x and x bar, y and y bar. That is why it is called xy plane. And the axes are called coordinate axes. X and y xy axes are called coordinate axis. Okay, now if we want to locate a point, here we will get what we have origin. Here we have fixed points 1 2 3 4 5, and negative point, negative is -1 -2 -3 -4 -5. Okay, above it will be 1 2 3 4 5, and below it will be -1 -2 -3 -4 and -5. Okay, if we want to locate a point P here somewhere, what we'll find, first we'll find it on the x-axis. So this point on x-axis is somewhere here, and on the y-axis it is somewhere here. So we can locate this point as 4 comma 4, because it is 4 units from origin on x-axis and 4 units from origin on y-axis. And in this bar graph we can see this point is 4 units from x-axis towards right and 3 units from y-axis towards right, above origin, and this is 4 units on the right of the origin on x-axis and above 3 units on the y-axis. So this is 4 comma 3 and this is 4 comma 4. Similarly, we can find other points on the coordinate axis. We can take any point. If you want to find 5 comma 2, we can find it. So this is our 5 is our x-axis and 2 is our y-axis. So 5 units on the positive side of x-axis, so this is this, and 2 units on the positive side, that is above, this is this. So if we mark a line here, here and here, we can find our point 5 comma 2. And we can name these points as P, N, M, whatever we want. Similarly, we can make on the negative side, for example, -2 comma -3. So this is our x-axis, this is our y-axis. So on the that is negative x, negative 2. Negative 2 means on the left side of the x-axis on -2. This is our point. Take it as A. This is our point. And -3 on the y-axis, that is on below origin. This one. Take it as B. And when we make a line here and here, we can find this point. So this point is -2 comma -3 on the coordinate axis. Okay, so what will be this point? Since it is on the origin of x, that is this point is on the origin of y, since it is not above any point on the above side or below side, so this is -2 comma 0. This point is -2 comma 0, and this point here is, since it is on the origin of x, so this will be 0 comma -3. Okay, next, slowly we'll get clarity. Again, we have one question here, one example number 1. See in the figure and complete the following statement. So first statement is, the abscissa and the ordinate of the point B are abscissa and ordinate of point B. This is what we have to find. And coordinate we have to find abscissa and ordinate and the coordinate of B. Okay, so what is abscissa? Abscissa is basically the x coordinate. Okay, and ordinate is basically y coordinate. Okay, so what we have to do is find the epsica and ordinate of point B. So we can see in the graph that B, this is the B point, and we have to find epsica and the ordinate. Epsica is basically x and ordinate is y. So the position of x here is on the right side, from origin and on fourth point. So we'll take 4 as epsica and ordinate as y is above the origin and on 3, so positive 3. So epsica and ordinate will be 4 comma 3. This is our coordinate. Okay, similarly point number 2. Now this will be easy for us. We have to find x coordinate and y coordinate of point M and their coordinates. We have to find the coordinates and points of x coordinate and y coordinate of M and the coordinates. So point number 2, x and y. So x coordinate of M is on the left hand side from the origin, and that is -3. So x is -3 and y is on the above from the origin, so this will be 4. So the coordinates of M will be -3 comma 4. Third, x coordinate and y coordinate of point L and hence the coordinate of L. So what we have to do again, we have to find the x coordinate and y coordinate of L and the coordinates. Where is L? Here. We can see here that L is on the left hand side from the origin on x-axis, and on -5, so it will be -5, and y, that is below the origin, therefore negative sign, and on -4, so -4. So the coordinates will be -5 comma -4. Fourth, the x and y coordinate of point S and hence the coordinate of S. We have to find x and y coordinate of S. So S is here. We can see here is that it is on the x-axis, on the right hand side of the x-axis, therefore it will be positive, and it is 3. So take it as 3, and it is below the origin, therefore the negative, and on fourth, so therefore -4, and the coordinate will be x comma y, that is 3 comma -4. Question number 2, example number 2. Write the coordinate of the points marked on the axis. So here what we have is, we have points which are marked here, and we have to find the coordinates. So here we'll put it as here like this. 1, we have to find A. Second, we have to find B. Third, we have to find C. Fourth, we have to find D, and fifth, we have to find E. Okay, so first A, the position of A. So we can see here is the A is on the right hand side of the x-axis and on the, so for A we will take x-axis as 4 and y as, since it is on the origin, since it is not, it is on the, in the line of the origin, of it is on the line of the origin. See here, it is on the line of the origin, therefore y has to be 0. It is not above, it is on the line of the origin. Therefore we have to take y as 0. So the coordinate will be 4, 0 of A. Okay. For B, we can see, for B we can see that it is on the origin line of x-axis, on the origin line of x-axis, like this one. Sorry, on here. So x-axis here is 0 and y-axis here is, it is above the origin and on 3. So y-axis will be 3. So the coordinates will be 0, 3. Third, C. Again we can see here is that it is on the negative side, on the left side of the x-axis. C is on the left side of the x-axis and on -5, and y is on, there is no y here, and it is on the origin line. It is on the origin line of y-axis here. Therefore y has to be 0. So the coordinate will be -5, 0. Fourth, we have to find D. Again here for x-axis it is on the origin line, therefore x-axis has to be 0, and for y it is on the below the origin, therefore -4. So 0, -4. E. For E, x-axis and y-axis. For E we can see here is that it is on the right side of origin and it is 21/3. Oh, sorry, 2/3. And on y-axis it is on the origin line of x, therefore it is 0. So it will be 2, 3, 0. This is the coordinate of E. Since every point on the x-axis has no distance from the x-axis, therefore the y-coordinate of every point lying on the x-axis is always 0. Thus the coordinate of any point on the x-axis are of the form x, 0, where the x is the distance of the point from the x-axis. Similarly, the coordinate of any point on the y-axis are of form 0, y, where y is the distance of the point from the x-axis. Because what? Because it has 0 distance from both the axes. Okay. And when the coordinate of origin, now we have to find out the coordinate of origin. So the coordinate of origin basically is, from on x-axis it is 0 and y-axis it is 0. Therefore the coordinate of origin will be 0, 0. Okay. Now one more interesting thing we can see here is, this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Okay. So all the quadrants that lie on the first quadrant, all the points that lie on the first quadrant will have x-axis as positive and y-axis as positive. We can see here also that all the quadrants on this plane, all the points on this plane will have x as positive and y as positive, because it is on the right hand side of the x-axis from origin and above the origin on y-axis. Therefore it is all positive. Second quadrant, Q2. On this quadrant, what we have -1, -2, -3, -4. Okay, so -1, -2, -3, -4. What we have here is, we have x, all the x coordinates on the negative side, on the left side. Therefore all the x coordinates will be negative, and y coordinates will be positive because it is above the origin and on the left side of the origin. Therefore the x coordinate will be negative and y coordinates will be positive. Any point on this plane will have a negative x and a positive y. Okay, quadrant 3. This is the quadrant. On this quadrant, x and y will be, since it is on the left side of the origin, so all the x coordinates will be negative, and it is below the origin, so all the y coordinates will also be negative. So any point on this plane, that is on the third quadrant, any point is there, x and y coordinates will be negative. Okay, quadrant 4. So quadrant 4, we have this plane. So on this plane, it is on the right side of the x-axis. Therefore the x-axis will be positive, and below the origin on y-axis, so y-axis will be negative. So any point on this plane on quadrant 4, x will be always positive and y will be negative. The coordinate will be positive comma negative, and on third quadrant it will be negative comma negative. On second quadrant it will be negative comma positive, and on the first quadrant it will be positive comma positive. Okay, now let us do exercise number 3.2. Write the answer of the following questions. What is the name of horizontal and vertical lines drawn to determine positions of any point in the Cartesian plane? We have to find the name of the horizontal and vertical lines. These are called coordinate axes. Okay, these horizontal and vertical lines are called coordinate axes, or x-axis and y-axis. Coordinate axis, that is horizontal line is called x-axis and vertical line is called y-axis. Okay, second, what is the name of each part of the plane formed by these two lines? So we have to name these parts are called quadrants. And how many quadrants we have? We have 4 quadrants. Okay, third, write the name of the point where these lines intersect. These lines intersect at a point called origin. Okay, question number 2. Of exercise 3.2. So what we have here is a figure, and we have to find the following. Point 1, we have to find the coordinates of the following. Coordinate of B. So we have to find the coordinate of B. So B is here. We have to find the coordinate. So it is on the left hand side of the x-axis. and it is above the y-axis, above the origin of the y-axis. Therefore the point will be negative x and positive y. Okay, so the coordinates will be negative 5 and positive 2. So minus 5 comma 2. Second, coordinates of C. Coordinate of C. So we can see here C is here. C is on the fourth quadrant, and on fourth quadrant we have x as positive and y as negative. X here we can see is on 5 by this dotted line, it is on 5, and y is on minus 5. So the coordinate will be 5 comma minus 5. Third, the point identified by coordinate minus 3 minus 5. So we have to identify the point by this coordinate. So minus 3 is x and minus 5 is y. X is negative, that means on the left hand side of the origin, and y is also negative, that is on the bottom of the origin, below the origin of y-axis. Therefore both these are negative, that means on the third quadrant. On the third quadrant it is minus 3, that means this one, and minus 5, that means this one. We can see the dotted line here. So this is point number E. This is the point. Fourth, the point identified by coordinate 2 comma minus 4. 2 comma minus 4. Here we can see that x is positive and y is negative. When x is positive, that means on the right hand side from the origin, and y is negative, that is below the origin, so that is fourth quadrant. On the fourth quadrant we can see x as 2, that means this, and y is minus 4, that is this. So this point will be G. Fifth, the abscissa of point D. We have to find abscissa of point D. Abscissa is basically x-axis. So x-axis of point D we have to find. So where is D? This is D, and we have to find abscissa. So abscissa is 6. Ordinate of point H. Sixth, we have to find ordinate of H. Ordinate is basically y-axis of H. So H, where is H? Here is H. So we have to find y-axis of H. Y is vertical, so, and it is minus 3. So it is minus 3. Seventh, the coordinates of point L. This is point L. We have to find the coordinates. We can see here is on x-axis it is on the origin line, so x will be 0, and on y-axis it is on the above from the origin at point 5, so it will be 5. So the coordinates of L will be 0 comma 5. Eighth, the coordinates of point M. We have to find the coordinate of M. We can see clearly that it is on the left side of the of the x-axis, or from the origin on the x-axis. So the x will be -3 on third unit, and y, it is on the origin line of y-axis, therefore y will be 0. So the coordinates will be -3, 0 for m. So here we have completed this chapter according to new syllabus. If you have any doubts, you can contact on ankitpublic11@gmail.com, or you can post a comment so that I can answer. I will try to solve your queries. I hope you have understood the concepts of coordinate geometry, and see you later. Goodbye.